Good morning. So I'm out here in my backyard. I know the other day that we talked about center of mass, and I said I was going to talk about collision. So it's a beautiful day, and I thought I'd come out here and throw some things around and show you some stuff about center of mass. So in just about every textbook that you find, you'll see a little stop motion film of a wrench that's being thrown. So here I have the ever popular, ubiquitous crescent wrench. And the center of mass of the crescent wrench, I don't know, let's see, maybe about there, okay? So once I throw it and I release it, that trajectory will be around this center of mass. The center of mass will follow that nice projectile motion, even though the object may be rotating. Okay, it could be rotating like this, could be rotating like this, it could be rotating like this, but the center of mass is always going to follow that parabolic trajectory. So hopefully you can see this. Here I go. Hey, it's stuck in the ground. Awesome. The ground is really wet back here from all this rain. I got a bunch of stuff here, a bunch of other stuff. Here's a plunger, toilet plunger. It's just a bunch of stuff I found in the shed. Yeah, okay, there's the balance point. It has a balance point here. All right. Okay. Maybe you can see this. Yeah, it wasn't so good. What about a ball? Well, we already know about a ball. It's a nice regular geometry. So you've got a center of mass that's at the center of the sphere. Nothing that interesting about this. Okay. Let's see what else I got here. Here's a piece of PEX. Last summer I did a lot of plumbing and put a lot of new PEX in the house. So now this is a nice regular solid. It's hollow, but also, you know, it's got a center of mass at the center. All right, here I go. Okay, a brick. Now let me get a little closer. Okay, here goes the brick. One more time. The brick. Okay. Here's an old exercise ball that I found. My wife probably threw it out. Anyway, you know, same as the tennis ball, right? It's a much bigger object, but the center of mass is at the center. Okay. So the next thing we're going to talk about is collisions. You know, objects. We're going to do 1D collision, so we'll do objects, you know, smashing into one another and bouncing off one another. And we'll have a couple of different special cases. We'll have a special case where we'll have two objects that come in and bounce off of one another. No loss of energy, okay, kinetic energy that is. And momentum is going to be conserved. Haven't even told you what momentum is yet, but you might have an idea. Okay, so what's going to happen if these two objects come in and hit one another? This one has a velocity in this direction, this one has a velocity in this direction, they have the same mass. This is like the pool ball problem. They're going to come in, bounce off of one another. Let's say that I have these two objects and some way or another they can stick together. Okay? So maybe one has, or they both have Velcro strips on them, they're the same mass, they come together and they stick. We'll talk about that type of collision. That's called a perfectly inelastic collision. That's where they come together and they stick. Momentum is conserved. Momentum is always conserved. Kinetic energy is not conserved. Okay? That kinetic energy goes into some other form of energy after the collision. Heat, sound, whatever it might be. Let's say that we have an object, a very heavy object. Now I know this exercise ball is not that heavy, but what's going to happen if this light object comes in and hits this? It's going very fast. This is stationary. Okay, we'll look at some stationary elastic collisions. So an elastic collision, like I said, is where the objects collide and there's no loss of kinetic energy, and momentum is always conserved. So if they come in, it hits this, it bounces back off, and this gets a little bit of velocity in that direction, or momentum in that direction. Momentum is a vector. It's a vector just like velocity. It's related to the velocity. Okay? What happens if this big object comes in? I've got a stationary ball. Big object comes in, hits this ball. This is going to go this way, and this is going to keep going this way. Okay? So in a lot of these cases, like I'm always telling you, you got to think about the physics. What's going to happen? Here's a collision. All right. Hey, it actually hit the brick. What else have I got down here? I don't know. So we'll look at some different types of collisions. We'll look at that perfectly inelastic collision where the two objects collide and they stick together. We'll look at the elastic collision, or perfectly elastic, where they come together and they bounce off, or they bounce like this or like this, okay, or maybe they're both moving at different velocities. So we'll talk about a bunch of different kinds of collisions after we talk about momentum and impulse. So I hope you guys are all doing well. It's a beautiful day. I would say get out, at least in the yard, you know, do something. So anyway, see you later.